We are going to talk about the interesting topic, demystifying Industry 4.0. The speaker is Shivkumar Srinivasan. We are having here, welcome Mr. Shiv. So handling business segments of automation, IT, strategic electronics and test equipment business at MELSS. He is the IT and business graduate with 16 plus years of experience, implemented cloud and big data solutions, several plant automation and Industry 4.0 solutions. Over to you, Shiv. Wish you all the best.
Thank you very much. So today my topic is really going to be about demystifying Industry 4.0. Now we hear this word called Industry 4.0 a lot, and okay, it's the next revolution that you're talking about, and it's something people came about when they hear the word cloud for the first time, right? Maybe about 10, 15 years ago, people talk about cloud and what's really the cloud, how different is it from the internet. So what I'm really going to be presenting here is trying to get us back to the basics. I know we've had a fantastic session before this where Dr. Mani talked about how AI is being used in medicine. And I know that you've gone through a lot of sessions yesterday, and there are other sessions which are going deep diving into special technologies, how AI is working, how you have machine learning, and how robotic process automation works. So what I'm going to be doing is get us to the basics, try to understand what Industry 4.0 is all about and how it's being used in the industry. So I like to normally run my presentation along the 5W and 1H questions, right? Where, when, what, how things happen. So that's easy for us to understand basics and the fundamentals of any topic that we want to discuss. So you talk about Industry 4.0 and then you say, okay, we've been doing work for so long, industries have existed, so what's so special? And you talk about robotics, artificial intelligence. Okay, so Industry 4.0 is a common term that you hear, and you have other terminologies that keep coming up. You have smart factory, you have digital factory, you have connected enterprise, you have smart manufacturing. Now, they're all related to the same thing, right? Different people try to explain or bring up the concepts that way, but fundamentally they all relate to how humans and machine, or in the sense computer systems, can collaborate with each other to make our lives better. Now, looking at the evolution, and this is probably a slide that you've also seen a couple of times in many presentations, right? So there's the first industrial revolution that started somewhere in the early 1760s, and then which really talk about mechanization, use of steam power, right? People started using machines, really, which can run on itself. Yes, you required manual operations, but then you leveraged a lot of physics, mechanical instruments to be able to do work. You then have the second industrial revolution, which was somewhere around the 1840s, where people started building mass production lines. Okay, so you have an assembly line, concept of assembly lines really started coming up, and then the invention of electricity. So rather than using steam power, you started using electricity to power up machines. The next is the third industrial revolution, which is after the 1950s, where you have computers and automation. So you bring in more interesting hardware that enables processes to happen, let's say even as simple as a timer-based action, right? You have your calculators and things that allow you to make. And now you have the fourth industrial revolution, which is your cyber physical systems, where you bring intelligence to the machine by itself, being able to operate autonomously, and how humans can benefit out of that. That's where the fourth industrial revolution comes from. So the basic principles of Industry 4.0. So why was Industry 4.0, or how do you conceptualize, right? It is built on, I would say, four main principles. That's what it's arrived at. So the first one being interconnection. So you want to have interconnection between devices, sensors, computers, and people, right? So different equipment must be able to communicate with each other. So you don't have to say, okay, has machine A completed something, now machine B starts based on that. Rather, we allow the machines to communicate between themselves. If one finds a fault, it can pass this information on to the next. The next is information transparency. So we are collecting enormous amounts of data these days. You have devices like wearable devices, you have RFID based solutions, Now, there's enormous amount of data that is being collected, and if this information is passed on to the operator of an equipment, right, it's going to allow him to take decisions much better or allow them to decide how their production must run. Right? The next one is technical assistance. Now, both humans need support from machines and machines need support from humans to be able to effectively and efficiently operate. Right? So we need technical assistance, and today we are talking about voice assistance or giving information in front of their eyes so that they are able to easily operate a machine, so training and things like that. So I would be touching upon a few slides on augmented reality, and you will see how technical assistance is greatly helping people generate better productivity. And the other thing is bringing decentralized decisions, right? So normally you have any networks, you talk about a central computing system, and then you have all the information that is collected, sent to the central server where the decisions are made and sent. So today we are in a fast-paced world, and we don't want all the information going back to the server for the processing. While yes, you could use it for a large analytics, but you would want to deploy the decision making to the end node, where decisions can be just made over there, decide should I do this or not. So this kind of decision making capability we want to move to equipment at the end node. So let's look at the pillars of Industry 4.0. Again, when Industry 4.0 was conceptualized, right, it is based main of 9 different technologies which was thought of as this is what Industry 4.0 revolution would really address. The first one being advanced robotics, and then you have additive manufacturing, you have augmented reality, you have simulation, integration, cloud computing, big data analytics, Internet of Things, and cybersecurity. So the first one is advanced robotics. Now in advanced robotics, the robots have existed for over 30 years, 40 years now. And so what's different between robotics earlier and now? So there are a few terminologies we really talk about. Number one being collaborative robots, right? If you've all visited any factory shop floor, right, it is still a mandatory safety requirement that you fence robots. You cannot work near robots. That's because you never know when they would go out of sync, when they can move, and they can definitely hurt you. So now we are talking about collaborative robots which help people do jobs which are, let's say, repetitive or it's dangerous for humans to do. These kind of jobs are going to be given to robots, and they work alongside humans so that they can help them do jobs which have to reduce fatigue, you could say. Yeah? And the other thing is autonomous robots. That's the next thing that's also part of this, where robots are able to communicate to each other, right? And today we are talking about production lines where you no longer talk about large volumes of same product. The concept has now changed, where you want every product that generates out of a production line is probably unique, right? You have customers who say, I'd like this car this way with the interior seating done this way with this variation of configuration. So every line product that comes out of a production line is different, and this is called customization, right? And to do this, all the hardware or the equipment that's on a production shop floor cannot be the same, right? They need to communicate and decide what next comes in and how this customization can be brought in. So these are examples of collaborative robots being put at work. So you can see that people, while these robots are not normally very large in size, they don't have a fence around them, and they help humans do certain jobs. You can assume, let's say there's a jig where you need to put 100 screws inside a piece of equipment. It's a laborious job for a human to go and then put this, whereas now a collaborative robot, once a human places a jig, it can take and start putting the screws in by itself in predefined parts, or again, that is again made more intelligent with camera-based systems where it can identify the exact hole. Even if there's an offset, it will be able to put it right through, right? These are collaborative robots. The next thing that we are talking about is additive manufacturing. Now, this technology is gaining a lot of interest in people, more so in research and development, where it reduces your life cycle of developing a new product or a prototype into a very, very small time frame, right? You will be able to generate highly complex designs which were not possible earlier, or if you had to do them, it's going to be very expensive or take a very long time. Let's look at an example. So If you see this particular design over here, right, to use a typical machine block and then start making the gaps this way is going to be very difficult, whereas additive manufacturing works by the process of adding points, right? So you take grams of particles, which could be different type of material. There are synthetic products available, metal available, that you keep adding and you fuse them together to make the specific design that you want, which otherwise is going to be extremely difficult for you to manufacture. Now this helps people come up with new designs, concepts extremely fast, and again, if you're not looking at high volumes and you're looking at low volumes, this is going to be a very good technology for people to be able to deliver products efficiently. The next is augmented reality. So there's a lot of talk about AR, and I think the most common AR examples today are to use mobile phones, and there are games that are available that people play with augmented reality. But what augmented reality is really about is to superimpose a computer-based image on your real world. Okay? Now this is an example of how augmented reality can help someone at work, right? So the device basically shows, you point at a specific equipment, it can help in training. It can tell someone, okay, you open the door this way, you make these modifications and so on. That helps people easily understand and deliver equipment. So the amount of training requirement is far lesser, and you also have real-time information that can come from the data analytics that you have made. This is a popular application from this furniture company called IKEA. So IKEA has an interesting application where you can take any of their furniture available in their catalog and try to place it on your living room and see how it's going to look at your living room background. This is another application of augmented reality. Augmented reality is also catching up in retail industry. So what we are talking about as the industrial revolution, the fourth industrial revolution, is not specific only to manufacturing capabilities. It lends to consumers and as well as for home-based applications where you can leverage. So you could probably walk into a shopping mall or a retail outlet, point at the aisles over there, and it's going to tell you, okay, what's free, and something, probably you bought something last time and then it can tell you it's on an offer now, or it can look at your patterns of purchase and say you probably are going to run out of a specific item this month. It's 30 days since you bought it and you're going to run out of it. So these kind of things Industry 4.0 can help deliver. So at work, augmented reality has different applications. It's also used a lot in sales. So you could go to a car showroom and then start walking around the car with an augmented reality device, and then you are able to understand how it is going to be. The next major pillar of augmented Industry 4.0 is simulation. Now we are not talking about games or 3D animation type of simulation, but with the amount of information that is collected, we talk about how you could simulate processes. Now when you talk about processes, a typical shop floor challenge that most manufacturing industries have is that in a shop floor, you need to optimize the machines utilization. You don't want them to be idle. You have invested a lot in having the machines, but as I talked about low volume, high variation products, they need to keep going to different equipment in your production line. And this is normally a major challenge for all production line managers. Now simulation can help doing production routing and optimization. It can tell you there is a possibility that this equipment is going to fail because it's already run X number of cycles, or we are monitoring the vibration on it, and it looks like based on historical patterns this is going to fail, so you don't put something through that line. It's going to cause a continuous line stoppage, you use your other machine, right? So predictive maintenance comes in there. It talks about how you could optimize your production if you say you swap some parts on it, and this kind of information that you gather will really help you make a better simulation. So we are talking about simulating and predicting, or what we can say forecasting how processes are going to be using the data that is acquired. Okay, the next topic is really integration. That's the next pillar that we are talking about. So when we say integration, see, software people, I think we're very familiar with integration between different type of software, but now we're talking about integration between hardware, software and different software being able to give us more benefits. Now, some of these terminologies are more used within the corporate spaces. So you talk about MES, which is manufacturing execution systems, which really talks to field hardware, you could say sensors or your machines, and they being able to pass information both ways to your customer relationship management solution, your ERP, your business process management, or your human resources. Now imagine that the field sales representative, right, he knows real time what's happening on the shop floor, or there's a customization that's required, they can feed this back straight away to the machines, and this is going to help them quickly make the necessary corrections on the production line. We also talk about automated value chains. So let's say you've just shipped your product out of your factory and it's on the way to the customer. This information can straight away go into your banks, your financing information, it can go to your distributor, and all this information, interconnection between different parties, right, that automates your value chain, necessitating all the manual entry can come down significantly. Integration with third-party data is also a very interesting integration that we talk about. Your integration with maps. Today you have Uber, Ola, all your food delivery services, which leverage a lot of mapping, traffic information to tell you your optimized route, how you could reach your destination the fastest, right? So these kind of information also help production, manufacturing and service organizations give a better solution to their end customers. Now, cloud computing. So talking about cloud computing, there is always these huge servers and data centers that we think of when you say cloud computing, right? Today, cloud computing allows even small organizations to get on par with very large organizations in delivering solutions. You no longer have to invest a lot in huge data centers. You get the computing capability as any large organization would do, and you're able to deliver solutions. The biggest advantage of using cloud computing is that the low total cost of ownership. You only pay for what you use, right? And you could also rapidly expand or contract the capacity that you have, allowing you to ensure that your investments are kept to a low. Big data. This is the other main pillar of Industry 4.0. So talking about big data, so you have millions of data points today. You have sensors across everywhere. You have cameras, you have face recognition, you have weather information, humidity, temperature. You capture all this information, and then you start analyzing them. You assimilate this information for you to be able to deliver a decision, right? So that's what really big data and analytics is all about. So there is a change in the way how you start looking at data. So when I was starting my career, right, when I go and talk to a customer, the first thing is, okay, how much of information do we need to acquire? And then you start talking about what is the hard disk space available, and do we really need to capture this information? Is it going to help us? What's the volume? Today, the concept of approaching a solution is changed a lot. You no longer talk about, do you need this information? You talk about, acquire the information, let's see what to do with it later, right? You start looking at, with this information, can the system then start delivering artificial intelligence and try and say it can make meaningful connections between different type of data which you would have never thought really has a relationship. And big data also allows us to do a lot of predictive analysis. As I was talking about in the past, you could predict. We were also having a session in the past where you're saying, can the vaccines and things that you have, they are going to predict to say when this person is going to require the next vaccine, or what based on the circumstances that they have, the geographical information, they are susceptible to something, is better for them to go for a periodic check, right? So the application can vary, but the data that we collect is going to help us analyze and give meaningful information. Now the Internet of Things, so how is it different from the normal internet? So on an Internet of Things, we are really talking about connecting a lot of devices together and them being able to talk to each other. So a good example at home is typically your Alexa or your smart home that's now coming up, which your Google Home or any kind of a product which allows you to connect to different devices, your light bulbs to the microwave oven, to a washing machine or a fridge. So this type of connectivity allows information to pass between equipment, and then they allow you to ease your day-to-day activities. So the key topic about Internet of Things is to have connected devices, right? All devices which are connected globally, and they are also being typically a cloud-based service. So you don't talk about within a small network, you get all this information to a cloud-based service and then leverage on the global data to be able to say how well something can operate. So you have machine-to-machine communication on a typical factory floor. You have your big data analytics, and you have your machine learning. So your machines talk to each other, and this information is then passed on for you to gather all this information for big data analytics. And with all this information, you're able to do machine learning, which allows you to look at patterns, make predictions, and also suggest to you how to make optimizations. This is one of the most important points of Industry 4.0, which talk about cybersecurity. Now you have billions of data points of information that you have. You would not want this to be available in the open market. You wouldn't want your competition to know how you are dealing. And there's a lot of discussions about privacy, even on social media. Your information being shared with others, or advertising agencies acquiring all your information, and they're able to give you targeted information. You normally feel violated in terms of your privacy. So the same is applicable even to an industrial environment or manufacturing space, where the cyber security is very important. You look at how you secure your information, how safe it is, and is it always available. You don't want to lose this information as well. The information must be available to you. There is no point in investing huge amounts of investments and finally the information is all lost, right? You don't want to be prone to hacking. You don't want the information go out of your control. So we've addressed what really Industry 4.0 is. The next thing we talk about why. Why do we really need Industry 4.0? Okay, there are a lot of these technologies, there are these different pillars. Why do we really need it? Now, Industry 4.0, you can look at it as any organization or a corporate company is in existence to give an anytime, anywhere product at the most competitive cost to their customers, right? This is why most organizations strive to do. And with regards to this, you look at Industry 4.0 as more as a business value evolution, right? Being able to give better business value. And it also eases the situation for manufacturers, being able to deliver solutions and more customized solutions to the end customers. And they're all designed as a made for me, right? So you keep putting your consumer at the center of everything that's designed around it. So you put them in the middle and you customize solutions for them. So who is implementing or who started this Industry 4.0 revolution, right? In 2011, it was started by the German government initially, right, at the Hanover exhibition. They brought up a roadmap saying, we have now come to the stage where we bring information as part of the industry revolution, right? And in the World Economic Forum in 2015, right, it was made as a global announcement that all countries must adopt the Industry 4.0 revolution, and that's going to enable overall benefits for the economy. Right? Now there are nation-specific movements that are being taken up on the Industry 4.0 revolution. Different countries have their own agendas and they promote Industry 4.0. So looking at where is Industry 4.0 being implemented. Now it's really not just a myth, right? It has really taken effect. So there are a lot of organizations in India, in Chennai, implementing Industry 4.0 solutions. In fact, we as a solution provider, when we talk to our customers, we find that a lot of companies now have dedicated budgets made for embracing Industry 4.0 solutions. Now, a study done in 2017 says that there was $66.1 billion of money spent on Industry 4.0 related initiatives, and in 2024, it's expected to be $155.3 billion spent on Industry 4.0 related thing. Industry 4.0 is not only to organizations who manufacture, it is also for government agencies. A lot of your public sector like your electricity, water, and these kind of agencies, also transportation, they use a lot of Industry 4.0 to understand, let's say, passenger traffic movement, right, and how energy is being consumed. So this is a distribution of Industry 4.0. This is again a research done in 2017 across industries who are adopting your Industry 4.0 related solutions. Yes, automotive always seems to lead the way because they have been at the forefront of manufacturing. But you can see that there are consumer electronics or pharmaceutical also getting engaged with that. Right. Again, Industry 4.0 deployed across the value chain. So you can see right from the manufacturing line to robots to having a supply chain to the end customer, you are able to collect information from them and then feed this back all the way to your manufacturing line. So when do we have to embrace or implement Industry 4.0, right? There's a very interesting visit that I made recently to a factory in Chennai, and this company has a huge Industry 4.0 push, and they have, I would say, 6 of the 9 pillars that I talked about. They have robots, they have automated guided vehicles, they've got augmented reality put into their systems, they are acquiring a lot of IoT devices, acquiring information from all their products to utilize and see in the shop floor how to optimize. So it is now, and I think this is when Industry 4.0 is, and we must adopt to it. Otherwise we are going to be left behind. It's a change in the way how industries work. So the concept of the business is also changing. We talked about who are real competitors. I think it's a famous statement you would have heard a couple of years ago. The music industry, who is the most biggest competitor? It was not the record making companies, it was the telcos, right? They are distributing all these music apps and all of them are being available. And similarly, the concept is also changing where today Rolls-Royce, who makes huge, okay, they are famous for their cars of course, but they make a lot of their huge engines, right, that power huge factories and aeroplanes and so on. They have moved to a concept of charging by the hour or the amount of power that their system generates rather than buying an equipment. So the conceptual change, and so you could probably say I'd like X megawatts of power out of your engine, and then that's what I'm paying for, right? So more people get to utilize the same services. And how do you adopt Industry 4.0? So you first look at your initial connectivity. So again, this is a slide very specific to manufacturing, but it can apply to any industry where you first look at connectivity, how you acquire the data. Once you acquire the data, you look at your process optimization to say, okay, based on this data, how do I optimize my process? You look at more automation, you bring in more standards, and then you look at the quality of this information, okay? And the last is look at new business models. Like I said, get into subscription-based services or things like that, which will allow you to deliver more and reach a larger audience. So this is basically the same as the previous slide. So we are talking about how you embrace Industry 4.0 in your day-to-day lives. So you could start small, start scaling at the edges, right? You start acquiring little information, right? It could be your wearable devices, it could be a field sensor. Acquire this information and then you build an ecosystem around it to be able to deliver a solution. Now any new implementation does not come easy. You always have challenges on them. So there are, I would say, while there are thousands of challenges in any new process, these challenges can broadly be classified in 3 areas. I would say you have economic, social, and political related challenges when you implement an Industry 4.0 solution. You've got a lot of costs. You're talking about implementing robots, sensors. So there's a lot of investments that you will have to do. It doesn't come cheap. And you're not clear about the economic benefits that come out of it. So it can be quite vague to say, what am I going to get by implementing all this, right? Is it really worth the implementation. You are not really talking about increased production going out or increased sales, which most organizations are looking at. So this, there is uncertainty on it. You also look at lack of regulations and standards. So you don't know whom to follow now when I say an industry 4.0. Okay, you've got the Amazons, you've got the Microsoft clouds, you've got robots from different brands. So which is the standard? How am I going to ensure I have a long-term sustainable growth by adopting one such practice? Okay. And with that, I end my note. Thank you very much. And
thank you, Shiv. Questions, please. There are a couple of mics, one in the back and another in the front. Feel free. Yes, please.
Can you please explain us with some use cases how augmented reality is used in mechanical industries or process flow industries?
All right. There are a number of places that are being used at the moment. I would say one is really to use mobile or tab-based devices for augmented reality, and the other is people are adopting to this new VR lenses, right, that you can add. Now, applications that have come up are quite interesting. So I have personally seen applications being used for maintenance management. That's a common application that comes up on industrial factory shop floors, where there is an equipment where you just point at it, is going to at the same time bring information from your ERP to say, okay, this is the scheduling that's done. It brings your maintenance information, your critical spares information about it, and it overlays everything on top of the equipment to say, okay, when was it last service? When is the next predictive maintenance due? How has this equipment performed over time against this industry average? Right? This is a very common example that's being deployed now with regards to augmented reality in production shop floors. Another very interesting implementation of augmented reality is coming in training and induction of new employees. Right? So when you come into either an office or factory floor, you don't have to bring trainees anymore and then start teaching them where things are located, what each equipment does, or how to operate a machine. So you also have now devices, projection devices that can sense movements and then project with light guidance to say, okay, now you press this button or you activate this or you load something here. One of the implementations I saw recently, there is an assembly line, right, where there's a board on which people are supposed to assemble different components. And they have a screen on top which has a camera looking onto the board, and it keeps suggesting, okay, this is the next component that you're supposed to pick up and place it exactly in this location. So it tells them, and it is able to identify the right part is kept or not. So if it's a different part, although it might fit in there, it says, no, this is not the right one. So it ensures that the mistakes are significantly lesser, and it also guides people. So the training requirements come down phenomenally, and people can be put to work probably within few hours of them being inducted into the organization. And another very interesting use case is for warehouse applications, where you have huge warehouses, you need to know which product is stored where, and then the augmented reality can guide you to getting the right product for you to deliver for the specific production or for your sales.
Thank you. Yeah, can you please?
Sounds very interesting and promising. Do you have any?
So I wanted to know, like you mentioned about the lot of opportunities and promising ways of implementing the 4.0 in various industries. Can you cite some success and failure stories where it has worked, where it has not worked? Just some examples.
Yeah.
Maybe in the automotive sector, did they adopt it and did they fail with the current situation?
Yeah. See, the success and failure really depends on how much somebody has gone into I would say architecting the solution, right? Now, you can look at predictive maintenance, or you're looking at artificial intelligence. Let's say that's one of the topics that we pick up. Now, artificial intelligence, the system arrives at a machine learning algorithm, right? You have an algorithm and arrives at a pattern. It addresses certain, it looks at possible patterns where it can recognize and say, if this happens, then you have something else change. Unfortunately, world is not that simple, right? It can do all those calculations based on the information it is fed, But if it is not fed with some information which is outside of the data that it has, then the entire algorithm or the prediction is wrong. It just does not work. Even today, I think most of the predictive learning algorithms, you talk about a single digit percentage which is really successful in being able to predict the right outcome, right? So it's still in single digits, it's not even in double digits yet. So we are talking about the information availability, right? So we as human brains, right, we are able to identify a lot more parameters, right? Look at nuances in things. It's just not always field information and sensors. Yeah, if there is change in temperature which you have not measured, for example, which can change something. You probably know there was a traffic jam on your way here, and a manufacturing facility is not probably getting traffic information why you started a production line late, right? So these kind of information. So I would say one of the main reasons for failure is architecting your solution or defining the boundaries of being able to make decisions. And the other is also simplifying things a lot, right? Yeah, it's very nice to make a presentation to say I can use collaborative robots. It's not that simple, as simple as it looks like, right? You talk about collaborative robots, designing something which would not hurt the person next to them, being able to do all your tasks, and your human fingers are probably the best devices that can adapt to any type of requirements, which a robotic finger, it cannot do. It's designed for a specific purpose, and it is governed by the physics that are surrounding them. So those are still huge challenges for people to be able to deliver successful solutions for Industry 4.0, I would say.
Thank you. In the interest of time, I would request the questions further to talk to Shiv, maybe a little offline. So there is a 15 minutes opportunity for connect. So please do that, and let's take an opportunity to facilitate on the behalf of Isaka Chennai chapter. May I invite Balaguru to present a small memento to Shiv. Thank you, Shiv.
Thank you. Thank you very much. Thank you. Thank you. Thank you very much.
Thank you, everyone. Thank you. Second. Third. Fourth. And the last.